Hello everyone, welcome to Unacademy. Today we are going to discuss about part 2 of entity relational model. Last session we learned about components of ER like attributes, entities and relationships. And in entities we learned about strong entity, weak entity, and what is the difference between strong entity, weak entity. We also proved that weak entity is established with the help of strong entity and weak entity is being formed using existency dependency or total participation or using one-to-many relationship. Today we are going to learn about the very important things, that is structural constraints and min-max notations and extended features of ER model. So what are the constraints are available especially in ER? So we know one of the drawback of ER model is nothing but you cannot implement all the constraints at a time, because the drawback of ER model is limited constraint specification. So what are the limited constraint specification? What are the constraints are available? We will look at into this part 2 of entity relational model. Let's welcome it. Before that, crack GATE computer science with us, top educators, quality content, great learning experience. Let's crack GATE CSC. Let's crack it. Crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded courses from India's topmost educators. About myself, Srinivasarao Sir, having 17 years of GATE experience in the subjects of database, computer networks, and operating system, having good certifications like database side, networking side, and operating system side. Also had industry experience as a database admin and system admin. Throughout my journey of GATE, I taught in many premium academies, which include of MEDICE, the GATE Forum, with high success rate of single and double digit ranks. Please participate and subscribe to our channel and also join in Telegram group for further updates and notifications. If you get the subscription, you will get daily live classes, live tests, and unlimited access to your courses, that is live and recorded lectures. There are two kinds of subscriptions are available, 12 months and 24 months. By applying my referral code, you will get it for 22,500. And 24-month subscription, you will get it for 27,000. Let's take the subscription and let's crack it. Let's crack GATE CSC. Use my referral code Sankara to get 10% off. Let's welcoming our session, that is constraints of ER. So when you talk about ER diagram, there are very important constraints are available. Number one, you can call it as structural constraints. Number two, covering constraints. Number three, overlapped constraints. So what are the structural constraints? Mainly, structural constraints describes or looks after the participation of an entity and the cardinality of an entity. Two important things. One is participation of an entity and the cardinality of an entity. That is the main role of structural constraint. What is a covering constraint? It looks or describes that whether all the constraints of an entity is being derived in the current entity or not. And what is the overlapped constraints? If at all a constraint is used on multiple entities, then you can call it as overlapping constraints. So what about structural constraints? Let us look into it. So as we learned that structural constraints mainly deals with two important things: cardinality ratios and participation constraints. So, what are the cardinality ratio? If you talk about the cardinality ratio, how many times the tuple of an entity or entity is appeared in the relationship, that's the meaning of cardinality ratio. For example, if you take there is a department instance and department number like 10 and 20 and 30. If I am keeping this under sharing, the sharing is nothing but a relationship. You see that how many times the 10 is appearing, how many times the 20 maximum can appear, and how many times the maximum number of times the 30 appears. This is the concept of cardinality. Cardinality mainly talking about that how many times that an entity or a tuple is available in the relationship is the concept of cardinality. So let us learn about cardinality. So mapping cardinalities are nothing but maximum number of times the instance of an entity is participating is the concept of cardinality. So it's nothing but maximum number of times a tuple of an entity occurrence in the relationship is a concept of maximum cardinality. There are two types in maximum cardinality. One you can say one, the other one you can say many. Therefore, the following are the cardinality rules. Number one, one to one. Number one to many. The other one, many to one. The other one, many to many. So, what is the meaning of this? Let me explain through an example of one to one. When you talk about one to one cardinality, so the scenario is like this. Let project entity, let project entity is there, and also let student entity is there. You say, I'm telling you one constraint here. Condition I'm specifying. What is the condition? A project can have maximum of 5 students. So how to represent this situation? This is what is the meaning of maximum cardinality. Maximum cardinality of project entity. Maximum cardinality of project entity. Therefore, you see that a project consists of how many students at a time. And the other one, if we are talking like this, I'm talking about again 1 is to 1 cardinality. So, what is the meaning of 1 is to 1 cardinality? The condition is like this. The condition is one student can take at most one project, maximum one project, and condition number two, one project can have maximum of one student. That's it. Now, what will happen? The entity or a tuple is appearing in the relationship from student to relationship is only one, and project to relationship is only one time. So, what is the meaning of that? Let us look at through an instance here. If I am taking a project entity here, project numbers like 10 and 20 and 30, And here I am talking about a student entity which consists of student number. Let us say there are few students are available. As we know the condition to prove that 1 is to 1 cardinality such that how they are going to be shared, I am representing here. So 10 will participate in the relationship and 20 also participated in the relationship and 30 also is participated in the relationship. So what will happen, friends? Here the 10 cannot appear multiple times, 20 cannot appear multiple times, 30 cannot appear multiple times, as he said that one project consists of only one student. Either it can be 1, 2, 3, no problem, but a project must consist only one student only. 1 is to 1 project this is. Now reverse, if you consider a student must take only one project. Any project you can take it, either P10 or P20 or P30, no problem. But you see that only a student can take only one project. So I am saying that student 2 is chosen project 10. So student 2 cannot take once again another project as it is restricted to one side and this side is also one. And student 1 must take any of the project but only one project can be taken. And student 3, there is only one alternative is there. What is that? Already S2 obtained 10, S1 obtained 20. So S3 cannot take 10, S3 cannot take 20 because here we understand only one project consists of one student. If you give like this, for example, then student wise it is okay. What is that? A student is chosen only one project, but other side project has got wrong. Why? P20 this time got two students, therefore it is invalid case. So we can say that this diagram is invalid or this entity relationship model is invalid because a project P20 has invalid because of what? P20 has two students. But as far as given constraint is a what? A project must have only one student. Therefore, this is invalid situation. So what is a valid situation? So when you talk about the 1 is to 1 situation, that should be like this. So if I am taking here project, the project has project number which is having 10 and 20 and 30 here. And if you take a student instance, the student consists of student numbers, the student number 1 and 2 and 3. This is a project 10 and project 20 and project 30. And both are participating in the relationship. One student can take only one project and one project can have only one student. So we are having a mapping. This is given to S2 and this is given to S1 and P3 can obtain only S3. This is the realistic situation. Therefore, you can say that P10 has only one student at max and the student also has chosen only one project at max. So you can understand, friends, what is the redundancy here? What is the redundancy? If you observe, P10 is mapped with S2 and P20 is mapped with S1 and P30 is mapped with S3. Therefore, redundancy is how much, friends? 0. Every row of a project is mapped only one time with the student. Other side is also every student who is going to take the project, only one project is chosen. Therefore, you see that this relationship is unique because none of the tuples are being repeated even in the project column, even in the student column. Therefore, this kind of mapping is the concept of what? Cardinality. Cardinality mainly talking that maximum number of occurrences is the concept of cardinality. Okay, friends. Now, what is the real-time situation of this? Library, you may take this example real-time. What is a library? You see, I'm going to write one constraint here. One student can obtain only one book. One student can obtain only one book. So once after written back, then you can obtain another book. And reverse also, same story. If I have only one copy, then therefore a book can be given to only one student. So this is one of the real-time situation of 1:1. For example, citizen versus Aadhaar. What is citizen versus Aadhaar? Every citizen has only one Aadhaar. One Aadhaar number can be given to only one citizen. Therefore, you cannot find any kind of duplication in that. So you want non-redundant data, then you're supposed to use the concept of 1:1 relationship. Okay, friends? So now we will look at into 1:many, that is another cardinality. So as we learned, 1:1, the redundancy is 0, and many to many, the redundancy is full 100%. Left hand side and right hand side columns can get 100% redundancy, but this and this, one side redundancy, one side non-redundant data. When you specify one, no redundancy. When you specify many, there is a redundancy. Again, I am repeating, when you specify many, there is a redundancy. When you specify one, there is no redundancy. That's why here both sides 1, hence redundancy is 0. Here both sides many, redundancy is 100%. Okay, friends. Now let us look at into one example for 1:1 and 1:many. So what is a 1:1? As we speak that an entity may be associated with at most one entity in other side, and E2 also at most one entity in E1 entity. He is talking that E1 is an entity and E2 is an entity, and both are participating in the relationship only once. Therefore, an entity of E1 will come only one time, entity of E2 will come only one time, and so we come to know that it is 1:1 relationship. Now, if you understand here, an employee can manage only one department, and reverse, department has only one manager. So what do we understand? There is a department number 10 which is managed by employee 3. So 10 cannot be managed by others, and E3 cannot manage any other department, as it is completely bound with this and this. Therefore, take another department and see that E3 cannot be manage the department. So we are going to take another employee as he is busy with 10 department. If you choose a 30 department, then you have to take another employee. Don't say that 10 and 20 and 30 will come here. Don't say think that E3 and E2 and E1 will come once again. That's why the redundancy in 1:1 is always 0. So come here. This is the representation of that. What is the representation of that? Here, an employee 3 is managing department 1. So E3 must not come once again. That's please remember. And D1 must not come once again. And employee 5 is managing department number 3. And next one, employee number 6 is managing department number 2. Don't think that you are going to get a concept called all employees are dealing with the 10 department. This is a wrong approach. Or you can say that this 10 department is managed by multiple number of persons. This is also wrong. Or you can say that employee E1 is managing multiple departments like 10 and 20, 30. This is also wrong. So in these two scenarios, you can see that friends, only left side instance will come only one occurrence, right time instance only come only one occurrence. If you look at 1:many, what is the meaning of 1:many? Let me figure out here. You say that there is a department entity and there is an employee entity. So departments are having a department numbers like 10 and 20 and 30. So employee numbers are here. So I am telling you, an employee can manage more than one department. Therefore, how I can do mapping here? I am doing a mapping that E1 is managing this 10, as well as E1 is managing this 20. So therefore, this E1 is what multiple times you can able to manage the things, and E2 is also managing here 30 department. Therefore, here what happened? E1 is managing 10 department and E2 is managing 20 department. For E1 is managing 20 also and E2 is managing 30 department. Here you can understand that we are getting E1 with 10 combination, E1 with 20 combination. Hence you can say that what is the theoretical representation here, that a department a department can be managed by employee. This is a condition number 1. Condition number 2, what is that? An employee can manage multiple departments, no issue. Can manage multiple departments. But earlier cases, one department is managed by one employee and one employee can manage only one department. But here, an employee can come any number of times with the combination of any kind of department members. We are writing once again the example such a way that a student versus project. A student can do multiple projects. So how I am doing? E1 is doing project number 10. So student number 1 is managing project number 1 and student number 2 can also run project number 2. Student number 1 can also take another project number 3. Therefore, the occurrence of this S1 can come multiple times with multiple projects. But you please understand here, friends, this is occurring only one time, but this is occurring a many time, and it is a concept of what? Many is to one cardinality. Now let us see how the one is to many is coming. What is the one is to many? Please observe carefully. This is one of your 2019 gate bit. Please observe carefully. What is an idea? Let us say there are two entities by name. Entity 1, it's nothing but table only. Entity 2. So an E1 entity may be associated with many E2 entities. That's the meaning of one is to many. An E1 entity can be associated with many entities of E2. But reverse, E2 entity may be associated at max with what? One entity. So E2 is a maximum 1. Look at other side. E1 maximum M. Always you have to look the maximum at the opposite side, not your side. Please be keep this one in mind. So many of you people do mistake here only. What is that? The maximum occurrence, always we will look at the other side. Therefore, here what is E1 maximum? If I am writing here, E1 maximum, E1 maximum, we will write here what? Many. Other side you have to see. What is E2 maximum? The other opposite side you need to see. What is that? 1. This is how you can able to designate the maximum cardinality of an entity. Okay, friends? So what is the example of one to many? So the thing is that an employee E1 is managing, please observe, project P1, and the same project P1 is also managed by employee E2, and employee E2 is managing here one more mapping, and employee E3 is also managing multiples. What I mean to say, an employee can manage many departments, but one department can be managed by only one employee. Therefore, the C1 is coming multiple times in this works on. Works on is a relation for us. It is a relation between employee and the project such that they're able to share the data. So now I will explain what is the meaning of a relationship, where and how it should be used. Please observe here, I am telling you, there is a department table which consists of department number and department name. And there is an employee table which consists of employee number and employee name. So there are some departments here, 10 sales, 20 accounts. Please observe friends, today class is very important to manage tomorrow's problematic class. So employee E1, there is something like Jones, and employee E2, something like Adams. Now you see, I'm asking two questions to all of you. Please respond. Find departments. So when I ask find departments, you will get the data from which table? The department table will give you department data. If I ask one more question, find employees, then you will get the data from employee instance. My question is, find employees who are working in departments. Find employees who are working in departments. Who are working in departments. Then this is a crucial. Why this is a crucial? Department table is giving department data. Employee is giving employee data. Therefore, I cannot get them individually. I am asking combinedly. Find employees who are working in different departments. I cannot say this. Therefore, what is required? There is a requirement between what? A relationship. So if I am taking this department number here, if I am taking the department number here, then I will come to know that who is working in whose department. Employee 1 is assigned 10. Employee 2 is assigned 20. Now you can understand that find employees who are working in departments. I can write here that answer to this is E1 is working in 10. 10 is mapped with this 10 and it will give you that he is working under sales. And 20 is mapping to 20 here and we will come to know that E2 is working under accounts department. So what is the meaning of relationship? The meaning of relationship is nothing but it try to provide sharing of data. You want to have the sharing of data, then there is a requirement of what? Relationship. Without relationship, you cannot have the concept of sharing of data. Even in relationship also, we want to identify how many times employee will come, how many times department will come. That how many times is the concept of cardinality. For example, I am saying here, there is a department instance which consists of department number 10 and 20 and 30. As we guess department name here, I say sales here and accounts here and operations here. 3 departments we are maintaining. And I am taking here employee instance, that is employee number and employee name. Now we have E1, E2, X and Y. Now my question is like this. What is that? An employee can manage what I mean to say multiple departments. Therefore, what happened? In the relationship, this is your relationship. In this relationship, I can able to manage what? Few important things. What is that? Department number and employee number. This is what is the concept of a mapping which we did in diagrammatically. Now I am showing you table format. That is employee E1 can manage 10. Employee E1 can manage 20. Employee E1 can manage 30. Therefore, what will happen? Your employee is repeated multiple number of times with the combinations of every of your department. So what is the meaning of that? An employee can manage multiple departments is the concept. The same we did in the diagrammatic representation such that an employee how we able to manage multiple departments here. The same I have shown you in practically like this. What is that? An employee is working in 10 as well as in 20 as well as in 30. This is the concept. So when you have this kind of a concept, it is a concept called one is to many. Reverse also you can call it as many is to one. In that one side you don't find the data redundancy, and one time you will find the data what? Redundancy. Either one side you will feel the redundancy, not the both sides. That's very important. Only one side you will have redundancy, one side you don't find the redundancy. Okay, friends. In order to do this kind of a mapping, what is required? There is a need of the relationship. So what is the need of the relationship? We use the concept of what? Primary key and foreign key concept in real time. Therefore, what happened? This department number I am using here as a what? Foreign key. Now you got the department number. Now you write here. E1 can manage 10 here, and E1 can also manage a 10 here, and E1 can manage a 10 here. So as many times you want, you can write as I have represented this. Okay, friends. So the use of the relationship is nothing but sharing of the data. The sharing of the data maximum is a M here, as we are asking one is to many relationship. If you ask one is to one, the maximum is only one occurrence. If you ask one is to many, the maximum is many occurrences. This is the concept. If I am saying like this, please observe. I will give you the scenario. Now you identify the relationship of them. This is the student. This is the course. And the course has got course number 10 and 20 and 30. 3 courses we are managing. Oracle and Java is another course. Android is another course. Now there are few students who are ready to take the admission. Student number 1, student number 1, student number 1. So student number 1, I am now mapping. Student number 1 is taking 10 course as well as 20 course as well as 30 course. So what is the meaning of that? A student is obtaining a multiple courses. Again same, student number 2 is taking a 10 course, and student number 2 is taking a 20 course, and student number 3 is also can take 30 course. So this kind of a mapping is a what? You can say one is to many, or other side also you can say M is to 1. Now I will give you another scenario. Please observe, friends. Every of this example you need to observe. You can easily score 1 to 2 marks, no doubt. So I am saying here, student is an entity and a course is another entity. Please observe carefully. And there is a relationship between them, because without relationship you cannot map the data. This is the relationship symbol. Yesterday I said, the last class we shared, this relation name is join. Student join for courses. Please understand, I am saying M here. I am saying a 1 here. So what is the meaning of this? It is a one is to many relationship from student to course, and reverse. Course to students, it is a many is to one relationship. Please observe. Student versus course, it is a 1 to M. Reverse you speak. Course versus student, it is a what? M is to 1. So what is the meaning of this ER? The meaning of this ER is nothing but, you people also might have guessed that a student can take maximum of how many courses, friends? Can take maximum of how many courses? Can take maximum of how many courses? How many maximum you want to say? You look at other side. Therefore, a student can take maximum of more than one course, many courses. And reverse, you tell me, what is that? What is the reverse? A course. A course can be given to how many students? A course can be given to how many students at a time? A course can be given to how many students at a time? A course can be given to how many students at a time? Look at other side. So a course can be given to whom? Only one student. A course can be given to only one student. This is what is the difference between one side and many side. One side you will have duplicates, other side you won't have duplicates. Clear, friends? Now we will look at into many to one. It's a completely opposite to one is to many. What is that? If there is an entity E1 and E2, and for sharing of them we are having the relationship name by name R1. If you think it like that, an entity may be associated with at most one entity of E2. Therefore, what happened? Where to write M? E1 at most with 1 means here. And what is the next one? E2 may be associated many times with E1. So what is E2 maximum? What is E2 maximum? E2 maximum cardinality with E1 is a what? M. So E1 maximum here and E2 maximum here. So E1 can participate only one time with E2 instance and E2 can participate many times with E1 instance. So what is the real-time example? An employee can work only in one project, but a project can have several employees. That's the meaning. Please observe. Employee instance, project instance. What this example is saying in such a way that there is a relationship between them. How the relationship is established. An employee can only work in one project. Therefore, the maximum of employee is how much? The maximum of employee is how much? 1. And a project can have several employees. So, project maximum is a what? M here. So, we understand maximum, we always look at other side only. When you talk about the maximum representation or maximum occurrence, it is only possible through what I mean to say, cardinality. So we observe 1 is to 1 and many is to 1 and 1 is to 1 and many is to 1 and 1 is to many cardinalities. 3 cardinalities we completed. Now we have the fourth variety that is called M is to M cardinality. So when you talk M is to M cardinality, it's a very good real-time instance. What is that? M stands for many. When I am saying many, it's nothing but what? Duplicates. Again, I am talking about many. When I am talking many here, it's nothing but what? M stands for many. Again, you will have the concept of what? Duplicates here. So you can have how many duplicates here? M is to M duplicate chances, or you can say occurrences. What is the meaning of that? E1 can participate many times and E2 can participate many times. Therefore, what will happen? E2 maximum is M and E1 maximum is M. So, what is the maximum number of occurrences? It's a very simple M is to M occurrences. Okay, friends? So, what is the real-time situation of this? The real-time situation of this is nothing but a student can take multiple courses. A student can take more than one course. More than one course. And reverse also true. What is that? A course can have more than one student. More than one student. Therefore, what happened? Student side is a M and course side is also M. Therefore, it is a M is to M relationship. So, look at the other side for the maximum representation. I have got like this. What is the student maximum? The student maximum is a M. What is the course maximum? It is also M. So, M is to M you will get the combination of the occurrences here. So we guess that it's 100% you will get the redundancy in this, completely opposite to 1:1. I will show you one real-time example how you can represent this in the relational model. I'm saying there is a student table and there is a course table. Observe friends. Student number and a course number. This is the primary key. This is the primary key. Now there are some rows are available S1, S2, S3, course 1, course 2, course 3. Now I want to have the sharing of the data. Otherwise you cannot able to know that course consists what are the students or student took what are the courses. So in order to have such kind of logic, there is a need of a relationship. So I'm taking the student number here and the course number here. So student number and course number are joined together. S1. So how many rows you can get? So it's nothing but SNO into CNO rows. So here 3 rows are there. Here 3 rows are there. You will get 9 tuples at max. Okay friends, what are 9 tuples? You can map them very easily. What is that? A student 1 can join for C1 and C2 and C3. So S1 is repeating thrice. And student 2 also join for C1 and C2 and C3. S2 is repeated thrice. In the same way, S3 join for C1 and C2 and C3. So S3 also repeated thrice. C1 repeated thrice. C2 repeated thrice. C3 also repeated thrice. This is what is the concept of what M is to M relationship. Okay friends, but the very important last class I shared, what is that? M is to M instance must be created separately. Therefore, how many tables you require now? Student 1 table we want to represent in relational model. Course also we want to create. This entity is a what? Associative entity because we are creating on the relationship. Hence there is a requirement of third table. So many to many always to be created as a separate table. Please understand friends. So let us take its definition. What is a many to many? There are 2 instances E1 and E2 and the relationship between them. So E1 entities can map with E2 entities many times. In the same way, E2 entity can map any number of times with E1. It's a M is to M relationship. The representation of real-time M is to M, an employee can work on several projects and a project can have several employees. But your final data is nothing but M is having every combination with your project combination. Okay friends? Now we come to very complicated thing. So cardinality is very easy to identify, but participation constraints are difficult to understand and digest them. So let me tell you one real-time case, then we go for a definition of participation constraints. Now you see, let me give you one real-time example. For participation constraint I am talking. There is student instance and there is a project instance. Now I am telling you like this. Every student must take project. Every student must take project, mandatory. And the point number 2, a project may or may not have students. It's not compulsory that every project is supposed to have students, but it's compulsory that every student must take the project. Every student must take project. Other side, a project may or may not have students. Now you come to the point. What is that? Student must take at least one project, but a project may or may not have students. So when I'm talking this kind of a thing, so minimum occurrences he is asking. Minimum occurrences of student and minimum occurrences of project. You observe, friends, when I am talking about a minimum cardinality also called as minimum occurrence, which is represented with two values. One value 0 and other value 1. There are only two flavors of minimum cardinality are called as a minimum occurrence. As far as this concern, minimum occurrence of a student, if you take that, every student must take the project. Therefore, at least one you supposed to take. And what is the next one? Minimum occurrence of project. A project may or may not have students. Therefore, a project sum x may not have students. Therefore, what is the value? 0. So, friends, you need to understand carefully. Minimum cardinality either 0 or 1. Maximum cardinality either 1 or m. Please observe carefully. Let me tell you. When I am talking about minimum cardinality, it is two flavors. You take or you may not take. But if you take minimum compulsory one. If I am taking maximum cardinality, already we seen in the previous examples, maximum you can take 1, otherwise maximum you can take m. A student can take only one project, or a student can take many projects. But here, a student may not take project, but a student must take project. This is may or may not. This is a must. And this is maximum 1. This is maximum many. This is also called as minimum 0, and this is also called as minimum. Okay, friends. Now my question is, please observe carefully. My question is, minimum cardinality, who is going to look after? Minimum cardinality, who is going to look after? Your participation constraints. Your participation constraints are dealing with what? Minimum cardinality. There are two varieties of participation constraints. One is a must, that is called total. One is not a must, that is called partial. Total participation and partial participation. If you look at maximum cardinality, the maximum cardinality is decided by whom? Cardinality only. Mapping cardinalities. What are the types are there? We learn 1 to many. Maximum I am talking. Many to 1. Maximum I am talking. 1 to 1. Maximum I am talking. M to M. Maximum I am talking. So minimum decided by the participation constraints. Maximum decided by the cardinality ratios, friends. Don't get confused. Minimum decided by the participation constraints. Maximum decided by the maximum cardinality. Minimum is total means compulsory. So what is the value? 1. Partial means not compulsory. What is the value? 0. Here maximum, I am talking about E1 to E2. Now you will come to know maximum of E1 in this case many. Maximum of E2 in this case 1. If you come to the second variety, maximum of E1 is a 1. If you look at E2 side, maximum of E2 is M. And the third one, maximum of E1 is a 1, and other one maximum of E2 is a 1 there and here, and next one maximum of E1 is that side M, and maximum of E2 this side also what? Yeah, that's it friends. So if you know the difference between participation constraints and mapping cardinalities, you will come to know. They are also called as mapping cardinalities. So mapping cardinalities will tell you how many times a row or a tuple will repeat in other instance. What is a minimum cardinality? Participation constraint tell you that whether you to take or not to take. That's the meaning of participation constraint. Must take means total participation. Optional take means partial participation. So what is the real-time example? Let us see with the definition. What's the total participation? Total participation is a compulsory you have to take. It is also called as existency dependency. Last class we learned about this. What is the meaning of its definition? Every entity in the set is involved in some association, compulsory. A tuple must come at least once in the relationship. So that's why minimum cardinality is how much? 1. Maximum doesn't mind. Maximum requirement is look after by the mapping cardinalities. The total participation, partial participation only consider or concentrate on minimum occurrence only. If you look at, this is an example for total participation. What is the meaning of that? Every employee must work in the department. Therefore, please observe, every employee must work in the department. Therefore, minimum occurrence is 1. Hence, when you make that every employee is a compulsory, he has to come at least once minimum. Hence, it's a total participation. Hence, its minimum occurrence is 1. If I am writing here, a department may or may not have employees. A department may or may not have employees. Now you see, it is called as a partial participation and its value is how much? 0. So a department may or may not employ, but every employee must participate at least one time in the relation. So what is the example? Please look at this. Employee E1 has to participate. Employee E2 has to participate. Employee E3 has to participate. Employee E4 has to participate. So please understand, wherever I kept the employee he has to associate at least once. But you observe carefully. D1 has got the employees. D2 has got the employees. D3 has got the employees. D4 not need. D5 no need. D6 no need, because we say department is a partial, employee is a total. So where whatever employee you keep here, he has to be mapped with at least one project. That's why it is a total participation. Every employee must take at least one project. A department may or may not have employees. This is the difference between total participation and partial participation. What is the total participation, friends? A tuple must come at least once in the relationship. What is the partial participation? A tuple may or may not occur in the relationship. Therefore, it's optional. It's called as a 0 value. So let me give some examples on total participation. Book is an entity and author is an entity. Both are participating in the relationship for minimum and maximum. Please observe the conditions carefully. This is wrote. Relationship name is wrote. The condition number 1. Every book must have author. Without author, you cannot write a book. Every book must have author. So once you are writing a book, means there is an author is existed. Point number two. Some authors may or may not write. Author may or may not write books. May or may not write books. Therefore, you may guess what is the total participation and where is the partial participation. So you also can chart now where is the book is a what kind of participation and author is a what kind of participation. Book is every book must have author. So therefore it is a what? Total participation. Every book must be associated with the author. Otherwise it's invalid. And author may or may not write books. Therefore it is a what? Zero. Clear friends? Let me give you the real-time mapping. This is the book. This is author. This is a book number. This is author number. Observe carefully. There are three books. There are three books. Every book must have author. Otherwise, it's invalid. So, book 1 wrote by A1. Book 2 wrote by A2. For example, book 3 wrote by something like A2 once again. And book 4, I am saying there is author A3. There is author A4 is also available. So A4 do not have any mappings here, but B1 has mapping, B2 has mapping, B3 has mapping, B4 mapping. Wherever you insert in the book, that book must be associated with author. But here, there are some authors who are idle, not yet started writing the books. Hence here, author is a partial, book is a total. Minimum should come only one time, maximum should come 0 time. Now we are talking about minimum occurrence only. The minimum occurrence decided by the participation constraints, two varieties, total participation and partial participation. So now we will see these are the total participation examples. So total participation, how are you going to specify? If you write like this, double arrow, it's a total participation. If you write a single line, it is a partial participation. Total participation is a double line. Single participation is a single line. That's partial participation. Let me give one scenario here. As far as this example concerned, the dependent, total or partial, employee is a total or partial, we want to decide. As it is a single arrow, then it is a what? Partial participation. As it is a double line, total participation. Therefore, what is the value? 1 minimum. Here, what is the value? 0 minimum. Plus. So now if I post one more example here, there is a E1 and E2. I am keeping a relationship between them. Please observe carefully. Double line, double line. What is the meaning of that, friends? You may guess. What is the meaning of the double line? We learned double line is nothing but what? Total participation. Every entity of E1 must come here. Here also total participation. Every entity of E2 must come here. Therefore, minimum 1. Here also minimum. Okay, friends. So you observe carefully. So this example you are able to say employee and dependent. What is the meaning of that? Employee and dependent. What is the meaning of that? Please observe carefully. This is weak entity. Please observe, friends. Weak entity is always with double. Weak entity is always with double. And this is strong entity. That's why it is a single. Last class I said very important thing. What is that? Every weak entity must be what? Total participation. I need not write the double lines here. It's not required. Whenever you say that there is a double rectangle is available here, then it is a total participation blindly, because every weak entity must be total participation. Or you can also say that every existency dependency is a total participation. So total participation, whenever I say, it is a what? Weak entity. Every weak entity is a total participation. Every existency dependency is a total participation. This side I can write it is a partial participation. Okay, friends. Now I'm telling you few important things. Strong entity can be partial participation as well as total participation. Please observe carefully. When I am talking about weak entity, every weak entity is a what? Total participation. You have to use like this. If you try to use with a partial participation, it is invalid, because weak entity always depends on strong entity. Therefore, every weak entity must be using a word total participation, but strong entity can go for partial as well as total participation. What is the difference between them? We will look at in this example. So when we are talking about weak entity, or weak relationship, weak entity means like this, and weak relationship means a double. Or when you talk about the existency dependency, in all the three cases, we use what? Total participation, either using a double line or using existency dependency concept like this, double diamond or double rectangle, or you may use double line. All three are representing that it is a what? Total participation or existency dependency or weak relationship, also called as weak entity. Now what is a partial participation? Every row may or may not come in the relationship. A tuple may or may not occur in the relationship. Therefore, minimum is how much? 0. So example, an employee may or may not work for a department. That's why employee said it is a partial, he may or he may not come. Now once look at friends, this is an example for partial participation. There are many employees are there. Some are not working in departments. Therefore, employee is a what? Partial participation. And department, every department I am having one association. Therefore, this you may write it as a total participation. But we are talking about employee as far as the previous consider. What is that? An employee may or may not work in the department. That is a diagram. So employee is a partial participation. Many employees are idle. They are not working in any departments, and it is called as a what? Partial participation. The minimum occurrence is a what? 0. May or may not write. But total means minimum occurrence is a what? 1. So what are the examples? Look at now. There is supplier and item. Supplier number, item number. So I say S1, S2, I1, I2. Please observe friends. every item must be supplied by supplier. Every item must be supplied by supplier. And the second point is supplier may or may not supply items. So now you understand what is the difference between them. What is the difference between them, friends? Supplier S1, I am writing mapping I1, S2, I2. So what is the meaning of that? Every item must be supplied by supplier. This supplier is not supplied anything. That's why he is idle. He do not have any kind of a mapping, because I can go for partial participation here, but it is a what? Total participation here. When I am saying total participation, it's a compulsion that the every item must be associated with the supplier. But when I say partial participation for the supplier category, a supplier may or may not supply items. So now I am writing both of them together, partial as well as total. Together they are producing a relationship to you. Please understand the constraints which I am telling you, conditions. There is a department instance and employee instance. Conditions are every employee must work for a department. Every employee must work for a department. Therefore, employee is a what? Total participation. Total participation means the minimum occurrence is a 1. And the next one, department may or may not having employees. It's not compulsory that every employee is formed in the departments. Therefore, it's a partial participation, and it is a what? 0. Symbolically also you can say, what is that? Single line, partial, double line, total. So minimum cardinality of employee 1, minimum cardinality of department 0. In the same way, you look at another example. Every employee must work for a department, so total participation. And every department must have employees, therefore total participation. So both side total participation, employee must occur, department must occur, and both side minimum cardinality is 1:1. If you look at another example, an employee may or may not work for department, and a department may or may not have employees. So both are partial, it's not compulsion. Therefore, what is the value? It's not a 1. What is the value here? Partial means 0 and 0. So 0 here and 0. Next example. This is a very, very important note. Very, very important. Examination concern. I already shared one important thing. What is that? Strong entity may or may not. It can be applicable for partial participation, can also applicable for total participation. But you look at the other side. Every weak entity must be a what? Total participation. You cannot use a partial participation there. Therefore, what happened? As far as this figure out concern, every weak entity uses a total participation, and every total participation may or may not be strong entity. What's the meaning of that? Let us see. When I am talking about weak entity, weak entity must depends on strong entity. Every weak entity must depends on strong entity. Therefore, it is the total participation. Compulsory weak entity means. But the strong entity may be partial, may be total, But every weak entity is a what? Total participation. You cannot use a partial participation here, but you can use both of them in strong. Why so? Let me show you in this. And one more thing I want to tell you. For example, there is employee and there is a department. I say employee name is a partial key and the department number is a primary key. So this is a strong entity. We know as it is identified a candidate key. This is the weak entity as it has got weak attribute. So whenever you have this kind of a situation, this is a total, no doubt. And this is a what? Partial. Between them, there is an association. Please understand. Every weak entity is a what? Total participation. That's what. Please observe. There is a customer and there is a license database. A customer may or may not have license. For example, under 18 years old, you cannot have license. Therefore, every citizen may or may not have license. So partial. But you observe carefully. Every license must be associated with a citizen or a customer. Therefore, license is a what? Total participation. Customer may or may not have license. It is a partial participation. But you observe in that case, every license is identified by primary key. Yes or no? Because license number is a unique. Every license number is a unique. When I identify a primary key, it is a strong entity. And here also it is a strong entity. But I kept total participation for license also. Why? License depends on customer. So what is the meaning of that? Please understand. Strong entity can use a partial and strong entity can also use a total based on the application. But here, every weak entity must be what? Total participation. So as far as that, you understand friends, even though license is a strong entity, but why we are using a total participation? Because of that, every license number is associated with the customer. That's why even though it is a strong entity, it depends on what I mean to say, total participation with the help of customer. Whatever license number you enter in license table, that must be linked with the customer, otherwise it's invalid. That's why every entity must come at least once in the relationship. But the reverse, a customer may or may not have license. That's why it is a what? Zero. Friends, again I am telling you that strong entity can be a partial, can be a total based on application. But weak entity must be a total, it must not be a partial. So the description here I have given, a person may or may not hold license, so it is a partial. But every license is associated with the customer, hence it is a what? Weak entity. Weak entity in the sense it's not a weak entity, even though it is identified as strong, but here totally participating on others. This is another real-time example. This is another real-time example. Person and Aadhaar. You know, every person may or may not be given Aadhaar, but you observe reverse. What is that? Every Aadhaar must be related to a person. Therefore, what will happen? Aadhaar is a strong entity. Why? Aadhaar is having a what? Aadhaar number, which is a unique, only one number to one Aadhaar. Even though it is a strong entity, we are doing a total participation because of what? Aadhaar must be related with a person. Whenever you enter some entry in Aadhaar, that must be linked to person. But it's not compulsion that every person is supposed to have Aadhaar. Therefore, it's a 0 and its minimum cardinality is 1. Same description I have given friends. Even Aadhaar is not a weak entity, but we are using a total participation because Every Aadhaar number is linked up with the other person. And there is a cardinality constraint. What is a cardinality constraint is, now I'm telling you like this, friends. Don't worry by seeing the diagram. Employee instance and department instance. I'm directly giving you one diagram. Please observe carefully. So what is the meaning of this? This is called cardinality. What is the meaning of this? Please observe carefully. I am giving you sentences. Employee minimum and maximum. You can also chat with me. And department minimum. Because every entity having minimum and maximum cardinality in real time. Minimum is decided by the participation constraint, total or partial. But maximum depends upon your cardinality ratio, like 1 to m, m to 1, 1 to 1, m to m. Now you decide what is employee minimum. What is employee minimum? Minimum means you look at whether it is total participation or partial participation. So what is employee participation? Anybody? What is employee participation? What is employee participation? It's a double line. What's the meaning of double line? What's the meaning of double line? It is, yes, good. It is a what? Total participation. So what is the minimum cardinality? What is the minimum cardinality? What is the minimum cardinality? Total participation means what is the minimum number? 1 or 0 that we want to identify. It is a what? 1. What is the maximum cardinality of employee? You need to look at other side maximum means. And department you have to look at other side maximum means. So department is a partial participation and the minimum is 0. And what is employee maximum? It's a 10. What is the department maximum? 1. So what's the meaning of that? An employee must work in one department and can work maximum of 10 departments. Reverse, a department may or may not have employees, but a maximum can have only one employee. That's the meaning. So look at, friends, this example. Identify maximum minimum cardinality from the following. What is that? SNO is a primary key. Project is a primary key. And there are some conditions. Every student must take a project. Must take a project. But can take maximum of 5 projects. Maximum. Project need not have students. But every project must have 10 students. So how to form? It's very simple. Student number and project. And there is a relationship between them. So student is a partial or total? You may guess. Student is a partial or total? Every student must take at least one project. Must take means what? Every student must take means what? Total. Compulsory. But maximum how many? 5. Other side. A project may or may not have partial. But can have how many students? 10 students. So student maximum is a 5 and project maximum is a 10. So how will you write the minimum and maximum cardinality to that? Student minimum maximum, project minimum maximum. So you may guess what is the answer. Student minimum. What is the student minimum? What is the student minimum? Student minimum, total participation, right? 1. What is the maximum? 5. What is the project minimum? 0. What is the project maximum? 10. So this is how you can represent total participation and partial participation with cardinalities, maximum occurrence also. Now I will give you a scenario. I will represent min max together like in a bracket. Like in a bracket I am writing. You please understand carefully. I will give two diagrams. Both diagrams are speaking the same. What is that? Student projects. This is another very important example, friends. As a student entity and project entity, both are under relationship, and student is a compulsory as per as the previous diagram. It is optional. Student maximum 5 and project maximum 10. The same diagram I wrote once again. Student maximum 5, project maximum 10. This diagram we can also represent using min and max notation. So there is one notation called min and max, don't get confused. In brackets only you will tell. That is the meaning of min max notation. That entity minimum only will be there, maximum also will be there, minimum will be there, maximum will be there. The first one is a minimum, the second one of maximum that entity, minimum of that entity, maximum of that entity. So I am writing the same diagram here. This is the student, this is the project, two entities. And this is a project entity. Now you see both are participating under relationship. Okay. Now I am writing there itself in the brackets. What is the minimum? Minimum of student. Minimum of student already we identified as it is a total participation. This is a partial participation. Minimum of student. How much? 1. Maximum of student. 5. Minimum of project. 0. Maximum of project. 10. So this diagram is equal. Here we are looking at maximum other side, but in the min-max notation we are looking there itself only. So minimum of student, it is speaking here only. Maximum of student, it is speaking here only. Minimum of project, it is speaking there only. Minimum of project, it is speaking there only. So in exam you will say very clearly that I am following min-max notation, otherwise it's going to be wrong. So if I am giving a situation like this, you take the other side, you take the maximum other side. But if I am giving min-max notation, minimum and maximum is available beside the entity only. So friends, this is the min-max cardinality of the previous diagram. Project 0 and 10, student 1 of 5. Same, already we have discussed here. Student 1 and 5, project 0 and 10. As the project is a partial, as a student is a total. So friends, you observe carefully next one. This is the last example for today's session. We are closing participation constraints and cardinality constraint. That's what today's class. There are two instances. S number is a primary key. Course number is a primary key. Every student must take at least one course. At least means total. Every course must have at least one student. It is also total. Student maximum can take 3 courses, and a course can have maximum of 20 students. So you can write here minimum 1, maximum 3, minimum 1, maximum 20. The same is represented in this diagram. What is that? Minimum 1, here also minimum 1, maximum course 20, minimum 1 of the student and maximum students 3. This you can write using min-max notation. What is that? Course and relationship with a student, and you have beside only we will write everything. What is that? 1 comma 20, 1 comma 3. First. So min-max notation is very easy to represent minimum cardinality and maximum cardinality of an entity. Well friends, so today we learned about 3 important things. One is cardinality ratios, which is nothing but maximum we learn 1 to many and many to 1 and 1 to 1 and many to many. We also learn participation constraints. There are 2 varieties, total participation and partial participation. Total participation means compulsory 1 and partial participation means optional 0. So participation constraints talks about minimum occurrence. Cardinality ratios talks about maximum occurrence. And we also learned about min-max notation. Okay friends, please subscribe our channel. Stay tuned to us for upcoming lectures and notifications. I have given you subscribed a template in the earlier slides. Please join in our Telegram group. If you have any doubts, I have given my number. You can chat with me on the WhatsApp and use my referral code to join in Unacademy to get 10% off. And for any kind of clarifications, not only for the subject, any kind of doubts you have, you can contact me. So take the admission in Unacademy using my referral code. For the more discounts, you call to my number. I will provide you more discounts too. Thank you very much. Stay tuned to us. Tomorrow we will continue the ER model and how you can able to map to relational model. That's very important question for us. He will give you a ER. We want to write its relational model. So that mapping, there are 10 rules are there. Those rules I will tell you tomorrow using some examples. So please meet me tomorrow special class 7:30 to 9:30 on Unacademy student learning app and 9:30 on YouTube class as usually. Thank you very much. Tabak khair.